we want to take a look at this piecewise function, and we want to make sure that it is continuous. But notice that this time, there are two unknowns, a and b, which are located in the second line in our piecewise function. So even though this function looks more complicated than the first one, we can still apply the same strategy as we did before. We want to make sure that two lines in the piecewise function have the same y value, where one line stops and the second one continues. So let's do that. Notice the first line in our piecewise function, 2x minus 1, it covers values from negative infinity all the way up to negative 1. And the second line in our piecewise function, it goes from values from negative 1 up to 1. Then our second function starts at the values of x equals negative 1. So we can create an equation out of this. We can set the first and the second line equal to each other. That is going to guarantee for them to have the same y values, but we want to make sure that this occurs at the x value of negative 1. That's where the first line ends and the second one starts. In addition, notice that the second piecewise function stops at the value of x equals 1, and that is exactly where the third line in our piecewise function starts, also at the x value of x equals 1. So we can create another equation out of that. We are going to set the second and the third line equal to each other. That is going to guarantee for them to have the same y values, and we want to make sure that this occurs at the value of x equals positive 1. So now notice that we have two equations that we can work with. We will use those two equations to solve for a and b. Well, let's start by looking at the equation on the left, and let's substitute the x values for negative 1. That is the x value that we want our function to have. On the left-hand side, 2 times negative 1, that's negative 2, minus 1, that's negative 3. A times negative 1, that's negative a. And let's bring down the b. In the function on the right, now let's make sure that it has the x value of positive 1. Well, let's substitute it into the equation. A times 1, that is just a. And let's bring everything down. So now notice that these two equations, the only unknowns are the values of a and b. Now we can solve this as a system of equations. I'm going to be looking at the function on the right, and I'm going to solve for one variable, whichever. I'm going to solve for a. So let's bring the b to the other side. So this equation is going to tell us the value of a. But notice that a is also present on the equation on the left. So let's take a look at this result that we got for a equivalent to 7 minus b, and let's substitute it to the variable of a in the other equation. And now let's simplify our result. Let's distribute that negative. That's going to give us negative 7. Let's distribute that negative. It's going to give us positive b. Let's bring down the second b. We can combine like terms. That is going to give us 2b. And now we can solve for b on the equation on the left. Let's add 7 to both sides. And let's divide it by 2. So now we have our first result. B is equivalent to 2. Now to solve for a, don't forget that we already have an equation here. But the benefit is that we already know what's the value of b. So let's get the value of b being equivalent to 2, and let's plug it in for the equation of a. If we distribute that negative, that's negative 2. And if we combine like terms, we're going to get 5 on the right. So we have our result. When b is equivalent to 2 and a is equivalent to 5, the piecewise function that we started with, it's going to be continuous. So this function of f of x, if we let a be equivalent to 5, and we let b be equivalent to 2, then the function of f of x is going to be a continuous function. Hello. If you would like to continue learning about mathematics, you can check out the videos on the left.